And we're live, according to YouTube. Hello, everybody. Hope you are doing well. It is 10 a.m. here today in Toronto, Ontario, Canada, February 28th. It is probably really cold outside. My name is Q, and I hope you're doing very well. Today, we are going to look at the animations and the mechanics that go into a draggable sortable list. So what I mean by that is this very pleasant little list we have on screen right now. So these guys are actually surprisingly difficult to build if you were to do it from scratch. So TLDR of this is if you can find a library that does this for you, just use it, just because there's a lot of complicated things that go in there. But knowing how they work underneath the hood is helpful, just because often, as thorough as some libraries may be, you still might need to do some sort of custom something. And when you do need to do that little custom something, it's helpful to know when and where to make those customizations so you don't break everything. So within the context of React, the most common draggable sortable kind of library today is, I believe, React Beautiful D&D. D&D for drag and drop, not Dungeons and Dragons, although Dungeons and Dragons would be cool. So this one is created by Atlassian, and these are the guys behind Confluence and also more recently Trello. And this is, of course, a very Trello-ish UI. They've released a very robust library that allows you to do very complicated draggy-droppy things. Outside the context of React, there is something called Sortable.js that you can use. This one is a vanilla JavaScript library that allows you to do sortable lists like so. Right? Cool. Underneath the hood, they all work with very similar mechanics and also animations. So how it works is we have a list. I'm not going to show the code right here just because right now it's pure nonsense. So just for a heads up, I'm going to approach this as, although this stuff is quite technical, I'm going to try to do it in a way that's as accessible as possible. So we have a list, right? Let's just assume that there's only one list. There's not like multiple lists, like a Trello card column kind of thing where you can drag into multiple lists and they sort and all that kind of stuff. No, we just have one single list with a couple of cards on them, right? So the moment you click on a card, it shows some sort of like dragging state, right? I have this guy, it's floating, and as I drag it down, after a certain point, the cards reshuffle, right? Just because, at this point, if I were to drop it like so, it should go into the second slot. And if I were to continuously drag them along, they would kind of reshuffle along the way, right? So that is the basic mechanics we have for this list. Jumping into Figma, before trying to wrap your head around how it is you're even supposed to code this thing, typically what I like to do is I just try to describe it with words, right? So I have let's see, 100, that's big enough maybe. Goodness. Hello. Okay, great. So we have a draggable sortable list. Cool. So what do I want? What do I give me 1 second. There we go. So what do we want to do? We want to, when you drag, when I drag or click, hold, drag an item. How do I? It's fine. When I click, hold, and drag an item, comma, it elevates. Okay? What happens when I move the elevated item to the spot of another item? They swap. Okay? And lastly, when I drop the item, the elevated item into an empty spot, it resorts. Don't know if that's a word, but that's basically it. So these are basically the requirements we have for a draggable sortable list. Okay, cool. Now we just need to figure out, these are the requirements. We need to figure out the mechanics that will make this work, and also how do we make it look nice with animations. And I do have chat open, no one's talking, that's perfectly fine. So we have number one. So what needs to happen is when I click and I start dragging one of them, so that means in terms of events, there needs to be some sort of click or drag trigger, right? This is the thing this is a trigger that lets your list know, oh, the user is starting to drag the thing, right? The other part of this is the draggable item needs to follow your cursor. My cursor. Sure. Okay, trying to keep everything the same. Yeah, so as I'm clicking and dragging this around, this purple ipsum square or rectangle is following my cursor. So we need to somehow write the code that makes it so. Otherwise, that doesn't happen. Okay? And that's basically it for the initial click and draggy part. The next part is when I move an elevated item into the spot of another item, they swap. So I'm just going to raise this here. So I have a little ghost, quote, ghost, number one, the original spot. Depending on the library you use, they may use different terms. So ghost item is one, a placeholder is also another one. Sometimes, depending on the library, they may not support it at all. For example, I think, I may be wrong, I think Sortable.js seems to support a kind of placeholder-y ghost item. What's another one? Funny enough, React Beautiful D&D does not support placeholders, at least not from the last time I checked it out. It may be different now, but I remember from before they did not. We can get into that a little bit later, but anyway, for demonstration purposes, I'm just going to have a ghost little one in this list so that we can see. So the moment that we drag the one over to the two, this needs to swap into here, but it doesn't do it right away. Here's the interesting thing. So if I were to jump here, I'm dragging the ipsum square, rectangle. It's not a square, it's a rectangle, into this blue dollar one. But you see, when the pink touches the blue, it doesn't swap right away. It swaps at a very particular point. I'm guessing when it hits the 50% mark, right? So that means initiate swap after elevated item has hit 50%. 50%, I don't know what the right word is, threshold of next item. Whoa, just bolded. So yeah, that is a little important detail that we need to consider. And here's the interesting thing. Depending on how you build this thing, I don't know if this is a bug or a feature, but during the swap, I can continuously move this guy around and and keep like triggering the 50% thing as this moves, and I just can kind of force it to do this forever. That's probably not desired, but it's fine. It's not, it doesn't break. It's just something to be mindful of. Yeah, so we need to swap this to here. So the moment that this hits 50%, whether it's going above or below, doesn't really matter. Once it hits 50%, it needs to swap like so, right? And if I continue to go down here, This will swap like, geez. This is very difficult to do over Figma. Oh my goodness. Please just swap yourselves into position. Great. Cool. And then the moment I drop this guy, it knows where it needs to go, right? The list has created a position for the one to go down. So as soon as I drop it, bloop, it'll go there. Resorts, kind of. Okay, cool. Yeah, so this is basically the high level detail of what we need to accomplish. These are basically the mechanics that we need. The tricky thing, once we dive in a little further, is how on earth do we get this guy to follow the mouse, first of all? And how do we do this resorting thing? So, depending on how the library or how you choose to animate these items, you can do it in one of two ways. So, in this particular case, this example is using the library React Spring. This is actually an example they've created, and using various things from React Spring as well as their sister libraries like React Use Gesture, they are able to math out all of the dimensions, the locations, and all that kind of stuff for all the things you're dragging and moving and dropping. But if we were to do this from scratch, the two trigger mechanisms that you need, or the two things that control how things can be moved, this ipsum rectangle, how is it can that be moved, is you either use mouse move of some kind. So every pixel that your mouse moves, either up and down, move the elevated item either up and down that exact pixel amount. So what I mean by that is if I move my mouse down 1 pixel, move elevated item down 1 pixel. This 1-to-1 ratio, it's quite important when you're building certain interactions, especially ones that need to feel very responsive, right? In order to make something feel responsive, it has to move exactly like how my finger swipes or how my cursor moves, a 1-to-1 ratio. If you wanted to make it feel like there's resistance, right? Like you're trying to drag something, but then after a certain amount of time, it pulls back a little bit. A great example is if you can imagine a mobile app, when you're doing swipe down to reload, the more after you swipe down, so let's pretend we have this screen. Let's pretend the circle is my finger that you can't see. Okay. Let's pretend the drag sequence, you start from here. Everything is fine, but the more you drag, this cover image or something starts, it doesn't respond as much as your finger. What happens is over time, the ratio of the sizing change, or whatever the change ratio, decreases. So in the beginning, it's a 1-to-1, very responsive. But over time, this number degrades to something like this. So just by looking at this, you can imagine the more you pull, the slower it responds to the user's action. This is kind of like an interaction design choice. It's not good or bad. It's just a tool that you can use. But in the case of our drag and drop little guy, we need it to be responsive. It needs to be 1-to-1. So that's something to be mindful of. Great. So if I move my mouse down, it should go down 1 pixel. If I move my mouse up, it should go up 1 pixel. It follows my mouse. Cool. We've established that. The other way to do this, this mouse following thing, is to actually no. This is fine. This is fine. The other way I was gonna mention is to use what's known as a request animation frame loop, RAF loop, RAF loop. So what this is it's the cycle of which your browser redraws everything on the screen, right? It does it 60 frames a second, and there's an internal cycle that keeps going. So you can create a loop that taps into that, and then for every single time the browser needs to redraw something, you would reposition something else to respond or to hook into that cycle so that the thing you're trying to animate follows along with it. This is very common for things that need to do something like this, very responsive-ish based kind of animations like carousels or drag drop things or anything of that nature. Anyway, so far this is fine. Just because when we move the cursor up or down, we understand that the rectangle follows our cursor. Cool. But how then, once we move our cursor over, say, ipsum, the pink rectangle, how does it know how much the square is? How does it know how to math the overlap and when to trigger the resort? So what needs to happen is, if you can imagine, how do I reset this guy? It's fine. I'll just duplicate it. I remember I saw a YouTube video a long time ago with a designer, and my apologies, I forget his name. DDG designer. This guy? Maybe this guy. No, it's not. He created field notes. I have to do this. Field notes designer. Draplin. Yes, this guy. He had a video where he talked about how he went about going to do logo designs, and he stressed the importance of being able to just dupe things within Illustrator just because it's basically free. So for you designers out there who just like need to just get lots of iterations out for something, something I found to be very helpful is just to dupe stuff. So here I have one iteration, I make this iteration, now I make this iteration, now I make this one. Just keep doing that. I've applied that principle into code as well when creating prototypes and stuff. It's very helpful. Anyway, we have our list. Now how on earth does a list know when it is to resort stuff? So the list must know certain numbers. The list has to know how do I draw lines? What's a good way to draw lines? Is this visible? That doesn't look very visible. I'm just going to draw rectangles. Okay. It needs to basically know the X and Y of every single item, if you can imagine. So 1, it knows the X and Y of that. 2, it knows the X and Y of that, and 3, and so on. And it also needs to know the width and the height of every single item. Okay? So let's pretend, with that mindset, you're Neo in the Matrix. You now know the values of all these guys. Cool. So every pixel, try not to imagine the square yet. So every pixel your mouse moves. So I'm going to draw a little circle. So let's pretend your mouse is here, right? This guy needs to, make this paint red. Yeah. So in order for this square to position itself to the mouse, right? Every mouse move event you have, the browser tells you where your cursor is, the X and Y of your cursor position in relation to the window, to your browser. So let's pretend it's at 200, 200. Exactly 200, 200. Can I write this down? 200 px. This is... The giant text is not working in my favor. It's fine. It's fine. You understand. So let's pretend that's where my mouse is, right? And because we already know the X and the Y, the exact location and the exact size of this thing, then we just need to use some math to kind of like, oh, okay, minus a couple of values and do whatever. And now we're able to perfectly position the dragging elevated one to our cursor, right? Now we have our mathematical formulas in place. Anytime we move this cursor 1 pixel in any direction, it'll just follow, just because we have those values mapped in. Now this happens. Awesome. So for every single pixel you move, right, the list is always running a test. Is the square that I'm dragging overlapping with something else? By something else, I mean the other items, 2, 3, and 4. Drag 1 pixel, do the check. Drag 1 pixel, do the check. It does a check every single time. And if there is an overlap that's happening, cool. How much is this one overlapping this one? 2, for example, right? If the amount that's being dragged is less than our specified threshold, which is 50%, don't do anything, because the requirement we have over here, right, is that the swap only happens if we drag it to 50% and beyond. So if we do this, nothing happens. The moment we hit 50%, the swap happens. Okay? Cool. So as we do this, we've hit 50%, which is around there. Hopefully you can see this. It's like, me as a list, I've done my check, and I see, user, you have hit 50%. Now I need to resort my list. So what information do we have? We have we know the exact location of every single one of these rectangles. We know the exact sizes of them. We know exactly where the cursor is, and we know that the user has dragged the rectangle 1 over rectangle 2, and that 2 needs to swap into rectangle 1. Okay, so that means that 2 needs to go to the location of where rectangle 1 was, if that makes sense. So rectangle 1 was here. We know the list. Let's pretend I'm the list. I am now a list, the sortable list. I, as a list, know where rectangle 1 was. You want to now? I need to move 2 to rectangle where rectangle 1 was. No problem. I know the exact numbers. I'll just move it. I'll just move it there. That's basically how it works. Where animations come into play. This is kind of the first time where you get an animation, just because when you have this kind of thing going on, it's not really an animation. It's just like a one-to-one direct responsive. You get any pixel you move, I render whatever it is, wherever it is your cursor is. There's no real like transition that's happening. I classify an animation to have some sort of transition of some kind. Here, when you drag your item into the list, there is an animation that happens, right? This gray rectangle sit will animate from position, the second position into the first position. So depending on the library or depending on how you choose to animate, you can use CSS transitions or use your animation engine however it is you see fit. You just need to move the item from the previous value. So let's pretend this one had, which one is, geez. This is why you need to label your layers. Why don't I label my layers? I don't know. That's a good question. So that doesn't help whatsoever. What is this? This one is a ghost one. Great. I can't spell either. Oh my goodness. Oh my goodness. Okay. Number 2. Number 2 is here. This one is rec2. Okay. Rec2. What was I saying before I got into my labeling my layers? What was I saying? Oh yeah. I was saying that it knows the values of its previous location. Let's pretend, to make things simple, the first location is 0, 0. Very top of the page, right here. If you can see my cursor, 0 from the top, 0 from the left. This one is 0 from the left, but maybe 100 from the top. round numbers, make it easy. So we need to move this guy from a top kind of perspective from 100 to 0. That's all you need. Those are the two numbers you need. 100, move it to 0. And then leveraging, say, CSS transitions, you can transition it from 100, translate x 100 to translate x 0. Sorry, translate y. I always forget this. Translate y 100 to translate y 0. And then the CSS animation will take care of the rest. So that is what happens. The sort is done. And you basically repeat that process for every single time you move this guy along. So we move this, it transitions up. But the moment, here's an interesting thing. The mechanics of the sortable draggable list has to also account for if you move your mouse upwards. So if you're dragging and sorting upwards, that way it can like do the inverse of that. It can shift back down. So items have to shift up, items have to shift down. Those are some things to consider. You can build that little calculation into the part where you're trying to figure out if you've hit the 50% threshold of the next item. You just have to take into consideration perhaps the direction of where you're dragging. And you can figure that out based on mouse move. Mouse move gives you what's known as a delta y. Mouse move, delta y. Or sorry, movement y. My apologies. I think delta y comes from wheel, which is another event. Anyway, what this is it just basically tells you the amount of the direction or the amount that has changed from the previous position of your cursor to the next one. If it's positive, that means they've moved down. If it's negative, that means they moved up. Very simple. And then based on that, based on that knowledge, you just calculate that against your 50% threshold, and you'll know whether to trigger the movement up or down. Cool. The last bit is we know as a list, we know all the values of these guys. We know where your cursor is so that we can show you the current item being moved all about, which is great. But how do we handle this when we drop it? So when we drop it, it needs to go inside of here, which is fine because, again, we know all the slots that are available. We have the mats, we have the dimensions, we have the locations every single one. So in essence, we just need to move this elevated selected item into the slot of where rectangle 2 used to be. Perfectly fine. The last detail of this, and this is something unfortunately that this particular example did not do, is let's originally let's have a list of this is not, I'm doing a visual representation of this list, right? In the moment that you drop one over here, ideally you want your list, your actual list in its raw data, in its data form, to be resorted as well. And that would of course reflect how they render, perhaps how they render into the DOM itself. So this one, it doesn't really do that. So here, I'm just oh Jesus. Okay, pay attention to the first rectangle, lorem, right? If I'm dragging it about, cool, things are animating. You can see lots of math and numbers and stuff flickering, which is great. If I were to drop lorem into the last position, visually we can see that lorem is at the very bottom. Great. But in terms of how they render here, that's not the case. So in this particular example, it didn't necessarily resort the data to reflect whatever it is you see on screen. I don't necessarily know if this is good or bad, but I would imagine that it's better. It would be good to resort your data so that it's kind of the same. So that's something that you have to take in consideration. It's probably better, I think, to do. And how resorting happens is you easiest thing is just to use some sort of library or something you can Google to figure out how it is you can resort an array. So we have a swap coming in from low-swap, which basically, it basically gives you an array, or you give it some values, right? The array, the current index, or the previous index of the next thing, and it'll swap it for you. So use some sort of library to help you figure that out, and you'll be able to get the new positions of where things need to be. And the very last thing you need to do is just save it somehow. Save the repositioned items into whatever state manager you have, whether it's local state, Redux, or whatever it is you need, and then the list will be resorted. And you just basically repeat this entire process, and you have a draggable sortable list. Something that you probably need to take into consideration, depending on the type of UI you need to build, is, let's see if this one does it. I need a long list. So React Beautiful D&D does do this. Right. So if you have a really long list, right? Let's say I want to drag this one and put it at the very bottom. That means that as soon as, so right now we know how all this is going, how all this works, right? The moment you hit 50% or some sort of threshold, the items will swap, everything is fine. But you notice how the window is scrolling to accommodate me moving this thing down. And it scrolls up to accommodate me moving it up. So you have to, depending on your use case and depending on the library, you have to consideration the user's intent for dragging and dropping and sorting a long list. So there has to be some sort of mechanic to scroll the list, either in its container or scrolling the entire window itself, to reveal either more above or more lower to allow you to have this interaction. So I'm just going to write that down. Last one is, I'm going to write this as a bonus. Bonus! Scroll window up, down to reveal more items if elevated item is near bottom or top. Top or bottom. So yeah, that's basically what this is. And it's basically understanding your X and Y of your cursor, your mouse. Where is your mouse? If your mouse is close to the top, cool, I'll start scrolling the list for you. If your mouse is close to the bottom, cool, I'll scroll the thing down for you. The interesting thing though is, this is extra bonus now, you don't have to do this, but this is nice, is the scroll speed. I don't know if you can tell from the screencast, but it speeds up depending on how close you are to the top and to the bottom. So going back to, going back to this threshold example, right? Let's say I'm going to draw a rectangle. This is not a rectangle. I need a rectangle. Thank you. And I need I need another rectangle. Yes. Geez. Okay, cool. So let's pretend this is the window. Jeez. No, please. Red. Just don't move. I need a lock. Don't move. Good. So let's pretend this is the guy, our little fellow that we're dragging around, right? And let's pretend this is the threshold for when we want to start triggering the scrolling of the window for you. So if you can imagine, right, I'm dragging this guy around, things are sorting, it's great. The moment that I hit this, maybe it'll scroll at a 0.5, a rate of 0.5. So it's scrolling at a pretty slow rate, just like this right here. If I hit this, it's not scrolling super fast. It's going at a pretty mild turtle speed, which is fine, right? But if I cross this area, maybe it goes even faster. I gotta elevate this over here. Like this. You can build something like this, and here, and then if I do it at the very bottom, that's when it's like, I'm gonna scroll this as fast as I can. So you can create zones for that can manipulate the scroll speed for where this guy is. So slow, slow, a little faster, a little faster, a little faster, and same thing for the thing above. Yeah, and that's a super bonus. You don't have to do it. It's great if your library support it, just because trying to figure all that out and like coordinating that with your draggable, scrollable, sortable list is a lot. So yeah, and I think with that concludes the high level mechanic and animation examination for draggable, scrollable lists. Some takeaways I'd say is, when you need to build a interaction or a UI of some kind, whether it's a draggable list, whether it's a carousel, whether it's multiple modals popping up with nested drop downs that do things, whatever the case may be, I always find that it's much easier to tackle the problem by writing out the requirements in plain English, point form, bullet points. When I do this, it should do that. These are the triggers. It needs to know this. After it hits this, then do this. Just write out all those various steps. Don't worry about design aesthetics. Don't worry about animation too much. Don't worry about the technical maths that you need to do this thing. You'll be able to figure it out. You can do it. You got Google. You got Google, you got YouTube, you have all these amazing resources. I trust you. You'll be able to figure it out. But yeah, start off with this bullet point form list. And after you do that, maybe draw these little squares. I do this all the time. I have a notebook, I draw squares, or I don't really go into Figma. I only ever really go into Figma when I need to do these screencast things, but I always draw squares. And pretend to play with them. See if you can find any requirements that may not be listed. Write them down. For example, we maybe discover, we need to magically scroll the window to accommodate the repositioning of the list. Maybe you need to do that. Write that down. After you do that, then you have a very good high-level idea for the requirements that you need to fulfill. Now you can focus on the mechanics. How do I, from a code standpoint, do this, right? Then you do it. You find the libraries, you do your research, you bang your head against the wall until you figure out how to math the positions of X and Y and so on. You get it done. And now you have the foundations of the thing you want to build: a draggable list, a sortable list, a carousel, whatever it is may be. And along the way, you may figure out other things that for example here, this idea of zones. Maybe you can take this and abstract it out and use it in another part of your application for other reasons. So maybe this idea of zones to either speed up or slow down something can be used somewhere else. That's not exclusive to just a draggable, scrollable list. I don't know, but yeah, it's an adventure creating this stuff. It's fun. Take it one step at a time. And if you let's pretend you never need to go anywhere close to something like this. If you need to implement some sort of draggable, sortable list, at least now you know what goes into creating something like this. So the next time you copy and paste an example from, say, React Spring, React Beautiful D&D, Sortable JS, or anything like that, you know how it works. And if you need to customize it, you may have a better idea of what it is you can tap into to customize the thing you need to do to get your work done. And with that, thank you so much for tuning in, and I hope you have a fantastic day. Catch you later. Bye. Ending the stream. Ending the stream. I have to announce this every time. End the stream.